Welcome to Chips of Math Physics. In this video, we shall continue our lesson on differential equations. And in today's video, I shall be using homogeneous method. Now, how can you know whether the equation is homogeneous or not? So, in our today's video, we are dealing with homogeneous methods. In homogeneous method, things you have to pay attention to is that f of x and y has to be replaced with f of kx and ky. So this is the first step. You must replace x in kx and y in ky. So you replace x with kx and then replace y with ky. If now you replace x with kx and replace y with ky, then you go ahead to check whether the function is homogeneous. If the function is homogeneous, then you go ahead to solve the differential equation using homogeneous method. And this is the only trick you need for you to solve homogeneous equation. Another trick that you have to be very versatile with is basic understanding of integration. You need to have the understanding of integration in your fingertips for you to work with homogeneous differential equations. So let us go ahead to pick a problem and check if it is homogeneous. If it is homogeneous, we go ahead to solve the problem using homogeneous method. So assuming that we are given a equation dy over dx is equal to x squared plus y squared divided by xy. First of all, we need to replace x with kx, and then we replace y with ky. If we do this, we simply have dy over dx will equal to kx. Now we have kx, but remember x is squared, so it is k squared x squared plus k squared y squared divided by kx ky. Now that we have replaced x with kx and replaced y with ky, we have to factor out k squared. If you look at the denominator, we are having k squared x squared and k squared y squared. So we'll go ahead and factor out k squared so that we will have dy over dx is equal to k squared into x squared plus y squared divided by, factor out k, we will simply have k squared. Remember, here we have k squared, so we will simply have k squared into x and y. If you observe, you will see that we have in both denominator and numerator we have k squared, so we can actually cancel k squared so that we get rid of that. Therefore, this equation, this function, it is homogeneous. The function is homogeneous. How do we know that it is homogeneous? The solution we've got is the original equation. Remember, this is the original function. X squared plus y squared divided by xy, and this is what we've got in our check. X squared plus y squared divided by x squared. So it is a homogeneous function. Now that we have verified and checked that the function is actually homogeneous, there are things you need to pay attention to in dealing with homogeneous methods when we use homogeneous method. You need to pay attention to some certain variables. We use v to be equal to y over x. This will imply, or this means that it is 1 over v, which is equals to x over y. Then you have to also be aware that y is equals to v of x. This is basically using u substitution. So dy over dx will be equal to x dv divided by dx plus v. You have to pay attention to this. You have to have this in your fingertips, as you will be required to use this dealing homogeneous method. So let's go ahead and see how we can apply this method to deal with this function. Our step 1, let me rewrite the original function. The original function is dy over dx, which is equals to x squared plus y squared divided by xy. Now that we have proven that this is indeed homogeneous, we have proven that it is indeed homogeneous. So what is the first step? The first step would be to divide all terms. We divide all terms by x. Remember, as you divide all terms by x, if x is you will only consider the highest term of x. In this case, the highest term of x is squared. So we need to divide this by the highest power, so that we will have dy over dx is equal to x squared divided by x squared plus y squared divided by x squared divided by, we have xy will be also divided by x squared. If you observe what happened here, x squared divided by x squared will simply give us 1 plus y squared divided by x squared will simply be y over x squared, and this will be divided by y over x. Now, as I have mentioned earlier, that when dealing with homogeneous equation, we need to pay attention to this formula. V will be given by y divided by x, which is given by 1 over v, which in turn will give us the inverse of the function, which is x divided by y. So now that we have divided all terms by x, we simply need to impute or try to replace v, which is what the formula says, using homogeneous methods. So the second step, we call it step 2. Step 2 in this form would be, let v be equals to y over x, and you know that I mentioned this earlier in our previous topic. So v is equals to y over x, and if v is equals to y over x, dy over dx will simply be 1 plus v squared divided by v. Of course, we know this by what we have in the function, because we know that 1 plus y divided by x squared, and by this will simply give us 1 all over v. So this is our v, but we know that v is squared divided by y over x, which is also v. So that is what I have done. We have to do now is to replace dy over dx. Dy over dx can be replaced by, if you remember what I said, dy over dx, it is simply x dv by dx plus v. So we are going to replace this. So we will simply have v, this is x. Let me take a very clear plan. We will simply have x dv divided by dx plus v, and plus v, this is equal to 1 plus v squared divided by v. 1 plus v squared divided by v. We can actually try to rewrite this so that it makes more sense. But before then, let me get rid of some of this so that we have space to write this. So we are working with x dv by dx plus v is equals to 1 plus v squared divided by v. If we try to make it more simpler, we simply have x dv by dx plus v to be equals to 1 over v then plus v. Now that we have separated this, we can actually cancel. We have v and v, so two of them we get rid of them, so that we are left with 1. At this point, we know that the function is separable. Remember, from the beginning we proved, we checked to see if the